So thank you, everyone, for coming out and knowing the tricks to get in the gate, even when they say the park is closed. I'm glad you guys are all in the know. So Meilani was just reminding me of, a little joke. This is based on, like, if a tree falls in the forest and no one's there to hear it, does it make a sound? And so I guess our equivalent is, if a monk seal's on a beach and no one's there to count it, does it make a data point? And I guess really it doesn't if we don't know about it. But so that's what kind of led us to investigate using remote cameras in some of our harder to reach places for counting monk seals. And so, of course, just starting out with a little about monk seals. So probably most people in this audience already know this is one of Hawaii's only native mammals, and it's actually the world's only tropical seal. And of course, they're highly endangered. So this is a really special animal, and that's part of why we devote so much attention to trying to understand things like the population trends and how many animals are in what different places so that we can help recover the population. And so, of course, Hawaiian monk seals only live here in Hawaii, so that's the entire Hawaiian archipelago. And so just zooming in on that, so of the seals remaining, only about 300 are here in the main Hawaiian Islands. About 1,100 are in the Northwest Hawaiian Islands. So those are the islands that start from Nihoa and go all the way up to the Kire Atoll. In that, there's a lot of variation of how many seals are in what places. And so in this color map, you can just kind of see, like within the main Hawaiian Islands, down on the Big Island, there's only fewer than 10 seals. But then you get up to like Oahu, Kauai, and Molokai all have around like 40-ish seals that visit our islands. And then going up to the Northwest Hawaiian Islands, some of the islands like Laysan is the biggest colony currently, and it's got over 200 animals. And then variations, smaller and larger populations within there. And so maybe one question, so of course in the main islands, we're interested in how many seals are on our island or some other island. But overall, why do we really need to care about how many seals are in which places? And the reason is because the population trends can actually be pretty different from place to place. And so these are just, let's see, there's my little pointer. So these are showing population trends. These are just for the 6 main sites in the Northwest Hawaiian Islands where we've been studying them the longest. And you can see there's a pretty big variation. So in general, the populations have been declining for decades, but you can see some variation within that. So in French Frigate Shoals, you can see actually really high. This number is actually 350, really high populations back in the 80s, and then a pretty steep and steady decline, but leveling out in the recent years, so that's really encouraging. But then to contrast that, you look at some place like Laysan that has been kind of bouncing around up and down around 250 for a really long time. And while it's gone down some, it hasn't been nearly the big precipitous drop, and there's been a lot more ups and downs. And then midway, you can see they were looking up, then they were down for a long time, and then just in recent years, really looking up. So understanding these trends and how they differ from place to place is really important for us to identify what sorts of factors are impacting the survival and the population growth or decline in these different spots. And so you actually have some of the major survival threats to monk seals actually vary quite a bit in space. So here we have a seal entangled in some old derelict fishing nets and ropes. And so that's not something we generally see in the main Hawaiian Islands, but that's something that's actually pretty common in the Northwest Hawaiian Islands. So up here, further in the Pacific, there are the Northern Pacific gyres, basically kind of swirling areas of water that end up circulating a lot of this debris, and then a lot of it falls out in the Northwest Hawaiian Islands. And so that's a major area for debris entanglements, and monk seals actually have one of the highest debris entanglement rates for seals. And then this island right here in the little yellow circle, that's Lisiansky. And so of the islands we've studied, that Lisiansky actually has the highest rate of entanglement. And so whether that's because of certain currents or the direction the beach faces, we're not quite sure. But by looking at these place by place, we get a feel for some of these localized factors. Yeah.
Can you go back to the last slide? Is anyone around who can, the one we put with the numbers on it?
Yeah.
Can focus that a little better? I'm sure the slide was.
I don't know. You know, to be honest, I think the slide is copied out of a document and the numbers are quite small, so I don't know that we're going to get much finer focus. But I guess, yeah. But yeah, so I guess the gist of it, so like for French frigate, we have numbers dropping from like 350 to just under 200. Laysan, we've got bouncing around 2 to 250. Lisiansky starts at around 200. Pearl and Hermes starts at around 250 and goes down. Midway is a much smaller population and it bounces around 40. And Curie bounces around 60 to 80. So yeah, thanks for pointing that out. All right, so after debris entanglement, mostly in the Northwest and particularly at Lisiansky. Then we also have food limitation is one of the really big problems facing seals in the Northwest Hawaiian Islands. And this is one of the major factors that limits juvenile survival and precludes population rebound up there. And this is a problem throughout the Northwest, but kind of particularly at French frigate shoals, which is shown here in the little yellow circle. Seals there tend to have it a little bit worse. And then shark predation, just kind of to add injury to insult. Shark predation is also just a particular threat at French frigate shoals, and that's probably one of the things responsible for that trend line really going down fast, because these Galapagos sharks at French frigate kind of developed a special skill, if you will, of targeting really young monk seal pups, just even while they're still nursing. And so, of course, we've been talking about the Northwest Hawaiian Islands. It's not all gravy in the main Hawaiian Islands. Seals here may not have as many sharks to contend with. They don't have as many seals to compete with food for, so food is okay. But then they have a lot of anthropogenic threats facing them in the main Hawaiian Islands. And so this is an X-ray of a seal that swallowed a fish hook, which, of course, can be very dangerous. So interactions with fisheries is one of the big anthropogenic threats that we see in the main islands. Trauma caused by violence from people is actually another big one. Anthropogenically introduced diseases like toxoplasmosis is another one. So there's a lot of, the threats vary from place to place quite a bit. And so basically what that means is our recovery actions vary from place to place and are very much informed by looking at those trends that differ from each of the locations. And so just to throw out a couple examples of the sorts of recovery actions that we do. So looking back at remembering the difference in French frigate shoals and sort of the long decline we saw there, and knowing that a lot of pups are going to die due to shark predation, whereas things are mostly stable just up the chain at Laysan. So we've had a translocation program where we will take seal pups once they wean from their moms, of course, and translocate them from the islands where survival is really, really poor to islands where it's much better. And so just within the Northwest Hawaiian Islands, we don't want to shake things up too much and bring them, really far afield. But that's something that we can do when we understand those differences between sites. And then rehabilitation of the emaciated juveniles is another thing that we're able to do when we understand the dynamics going on from place to place. And so this up here, this is a little seal that we picked up a couple years ago from Laysan Island. And he was returned nice and fat and happy this field season. And then these are a couple of seals swimming around at the Keikaiola Rehabilitation Center on the Big Island. And then, of course, on the main islands, a lot of what we do to try to mitigate things like the anthropogenic threats is a lot of outreach and education. A lot of volunteers help us out with this. There's a bunch of folks in the audience that help us out with this. And then, of course, the barbless circle hook that's part of the barbless circle hook program that's part of NOAA does a lot of work trying to get folks to use fish hooks that might be easier to remove or harder to get stuck in animals to try to alleviate some of that hooking danger. So that kind of brings us to, okay, so now we know it's really important to understand different trends in different places and what's going on with monk seals. But so how do we survey for monk seals and how do we get a handle on that? And actually it differs quite a bit from place to place. So throughout most of the Northwest Hawaiian Islands, so the major, so this is like from Laysan up to French Frigate, we deploy remote field camps every summer. We actually just had our last field camp come back from French Frigate Shoals this Tuesday. They were all very scruffy and sunburnt. But so those field camps spend 3 to 5 months out camping on these islands, and they do systematic surveys. Like some surveys, they might have 2 hours to get around the entire island to count how many seals are there, or they have to cover all of the islets within the entire atoll within a day to count all of the seals within a set period of time. And so it's really systematic and repeated over the course of these months. So we get really tight population estimates for these islands. So sometimes we can say, we know we have counted every single seal, or if we haven't counted every single seal, we're able to estimate the population within a really small range of error. And then for the main Hawaiian Islands, we rely a ton on public and volunteer reporting. And a lot of you will recognize this guy. This is DB, who is kind of one of the most super reporters of seal sightings that we ever had. So his loss is felt for sure. But we get DB and then others, we get thousands of reports of seals every year. And so this gives us a couple of things that are really great. We get year-round coverage, and we get a ton of reports, but it's not very systematic. So we have some beaches that might be missed. So like if a seal hangs out at a beach that's really difficult to get to or unpleasant to walk to, probably they don't get counted very often. And so since we don't have, since reports getting called in don't necessarily have that same sort of survey effort behind them, we aren't able to use the same statistics to estimate the population. So what we get from the main islands is a little bit more of like a minimum count. If we counted 44, we know there are at least 44. There's probably a couple more that we don't know about. And then we have the kind of intermediate islands, Moku Manamana and Nihoa. So these are both high islands just at the start of the northwest chain. And they have really small beaches. They host much smaller seal populations. They're very rugged, difficult to get to, and also have a lot of cultural significance. So they're not places that you just sort of willy-nilly put up camp on. So these are areas that we don't have permanent camps, and of course no one lives there to report seals. So these are sort of data shadows for monk seals. We don't have nearly as good a handle of the seals on these islands because we only get there maybe once or twice a year as we're on our research cruises going up or down the chain, dropping off our field camps. And so the population estimates from here are quite a lot more uncertain. And I think I've got a little video for you guys to see. This is one of our crews getting dropped off on the rocky landing at Nihoa to do a seal survey. And this is a really good weather day. I just want you to know this is the fine conditions. But so you kind of have to have just the right conditions in order for the boat to be able to butt up against the pokey rocks and get the people off safely and not get in trouble with the tides and too much surf and all that good stuff. So this is one of the reasons it's really difficult to get to. So sometimes even if we're on our cruise headed up there, if the winds are too high, it's not safe to bring the small boat here and do this. So then we just miss a survey for that year. So we've got some hard to get to places and hard to get data. And so here you can see these are some discovery curves. So these are basically curves showing, remember how I was saying sometimes we know we've counted them all. And the way we do that, so along this axis, this is numbers of hours of survey effort. And you can see they go in hundreds, so from 100 up to 800. And then these are numbers of seals identified, 50, 100, all the way up to 200. And so basically we can track for how many hours of survey effort in the field are we still finding new seals. So if you've gone out to a beach every day, you saw, let's say you went out to Caimanas today and you saw Rocky. If you go out to Kaimanas every day and you only ever see Rocky, you're like, all right, I'm good. I got it. I know all the seals on Kaimana. If you go to Kaimana Beach every day and like one day you see Rocky, one day you see Kaiwi, the next day you see Benny, the next day you see someone else. Every day you go, you keep seeing new seals. You're like, okay, I haven't gotten them all yet. They keep showing up. There's still more. So that's kind of what we're doing statistically with these discovery curves. We're basically saying how many hours do we have to spend before we are not seeing new seals anymore. And so when these lines flatten out, that means we got them all. So for that site, we're really comfortable. We have a really nice, tight population estimate. So like you can see this nice flat line with Laysan, and you see these points. Occasionally we had a bad year where we had maybe shorter surveys. So you see this little error bar here. We're like, oh, there's some uncertainty in our number, but mostly it's like, yep, that's a point. That's how many seals there are. We've got a really good handle on it. And then you compare that with here's NOAA for the same, for a number of years. And so you can see we might have gotten to the beach. Oh, whoops, sorry, I forgot I have animations. But so for NOAA, you can see we might have gotten to the beach, we counted some seals, then we got to the beach another time, we counted a totally different number of seals. So we think the population might be somewhere in between there, but the error bars, it could be way more, way less than that. And so you can see with the blue lines that have just popped up for Laysan, we can say, yep, we've got a really good handle on this trend. This is totally what's happening with the Laysan population. With NOAA, it kind of looks like maybe it was going up. There might have been a dip, but then it's going up again. But keep an eye on those error bars. That says, well, the population, you know, we think is at this point, but it could actually be all the way up here, all the way down here. So maybe the population is actually going down, or maybe it's actually going up. It's kind of hard to get a handle on the trend when you have really big error bars on your estimates. And so that's where we want to know, how can we get more data from these hard to reach places where we can't get there multiple times a year and we can't camp there. So, we get a hobo to put a camera on a beach. It's actually not a hobo, it's just a field biologist that was out at French Frigate Shoals for a very long time before we made him put a camera on NOAA. And so here you can see NOAA. You can kind of, this is a top-down picture, so you don't even actually get a view for how rugged it is. But what you can see is that there's really just this one little strip of beach, and this is where the monk seals like to hang out. And so this is part of why this whole camera scheme seemed like a good idea for NOAA, because the seals are really concentrated in this one small spot. If we had to try to survey every angle all the way around an island with a camera that's stuck in one place, there'd be no way. But when you actually have something natural that kind of funnels the seals into one place, it could work. And so what we did, so you've got here are the guys up on a cliff putting a camera on the east side of that beach. And so it's on the east side looking west. And then this other camera is on the west side looking east. So hopefully these cameras are sort of crisscrossing the beach and we get a good complete view of all the seals. And so we set up these two cameras. And so each one is just basically a simple digital SLR camera, but then, and they're set to shoot photos from sunrise to sunset. And on different years, we've changed the settings from everywhere from every 10 minutes. We realized that was way too many photos to deal with. So then we switched to every 30 minutes, which is still way too many photos to deal with. But it's nice to have coverage all day. And so you can sort of see in this picture, wanting to be sensitive to the sacred island, we put the cameras in place by putting the cameras onto a wooden sled and then weighting that wooden sled down with sandbags so nothing's actually drilled into the island. And then in this little protective box, you can see they've got a 12-volt battery. This is the voltage sort of regulator. This is the time regulator where we set how many seconds and so forth between photos. And then they've got a little solar panel that keeps them going throughout the year and a bird poo shield to keep our camera lens from getting completely discombobulated over the year. And so we put these out in 2013 and we already have over 100,000 photos. So this is a lot. So for you guys that enjoy going out watching seals, looking at seals, imagine looking at 100,000 images. And And we found out a lot about Nihoa Island. So for one thing, we got to see the variation across the year. Because remember, we get on this island once or twice a year going up and down in the summer for our field camps. And so once we saw the entire year, we saw huge variations. Sometimes the entire beach disappears and there's a ton of rocks during these storm surges. And then sometimes it's a huge sandy beach and there are seals everywhere and they're easy to see. And so some of the things we're looking for when we're looking to see those seals, so we want to know how many seals are out there. That's really great. But we also want to know which seals are out there. We would like to be able to identify individuals and see if they're showing up time after time so that we get an idea about their survival, whether they're staying in one place or going far away, whether they're having pups, whether the pups are surviving. And so there's quite a number of marks that we can look at to try to identify seals. So one of the really nice obvious ones are flipper tags. But of course that could be difficult to see in a photo if it's a little far away or if the seal happens to be folding up its flippers. So there are also natural bleaches. So just a little light mark that occurs naturally on the seal's skin. Then you also have pups. When they're new and they're small and they're black, they're really characteristic and pretty easy to see. You can have some pretty extreme scars on seals, sometimes from shark bites, sometimes from mounting wounds when females get mobbed by a number of males, sometimes little cookie cutter sharks that make these nice, really characteristic little round marks. And then of course, if we've been to the island recently, there might be some unnatural bleach marks where we have actually bleached a number in the seal's fur. And so that can make them stand out really nicely as well. So I've got a test for you guys now. So here's a number of seals at Nihoa. And yeah, anyone used to looking at seals on main Hawaiian Islands beaches is probably just going to be amazed by the number of seals here, period. But find an identifying mark on any of these seals. Can you find and identify, so those marks we just looked at, like a bleach mark or a scar or a tag, can you see any on any of the seals?
Better resolution and zoom in.
And it's a little better resolution on my screen than when it's blown up on that screen, but still, there's limits to technology. You don't get to ask the seal to roll over. You don't get infinite zoom ins. All right, anyone? I think Marilyn sees one. You see at least one shark bite? All right, yeah, I think I'll get to it. So this one has a little natural bleach on that back flipper. If you look now that it's in the circle, you can kind of see the light mark. This is what my interns get to do all summer long. So definitely tell your kids to sign up. It's great. This one has a temporary bleach mark that I believe is number 25, and it's really hard to see. This one has kind of a big scar from a mobbing wound. I think, is this one the one you were pointing out, Marilyn? Yeah, that one's got a nice big, like a mobbing scar plus a shark bite. This one has a little white finger on its flipper. So all of these are seals that, as we mark these and as we continue to go through photo after photo, we might see these same seals over and over again and start to get some idea about their survival. And then we can also say, like, well, if we know this many are marked in the population and we see the marked ones this often and the unmarked seals all the time, we can start to estimate that population a little more closely. Yes, yeah, all of these photos, these are the photos from those remote camera setups on Nihoa. Yep, and I believe this is from the west cliff. So now here is Nihoa in a storm, and who can spot the seals in this picture? It's a little harder when they're not on the sand, right? Okay, I'll give you a second. Everyone spot which shiny rocks you think are seals. Okay, I feel like there's some consensus. Is this one that everybody found? That's the popular one. Did anyone find another seal? Oh my gosh, you guys are good. Is it that one? Everyone kind of see, can actually see his little face right there. Did anyone find one that I missed? Can you get them? All right, so the conditions in the photo can make it much easier or much more difficult to try to get a decent count of the seals. But we also get some things, like I was saying, the pups can be pretty obvious. Now this one's more of a gimme. So how many pups do people think they see in this photo? Just shout out some numbers. Wow, that's some consensus there, yeah. Were they those two? Yeah, so even if it's hard to get exact counts, we can actually maybe track reproduction pretty well, just because a tiny black pup is a really characteristic thing to see. It looks really different than sand. It looks really different than the other seals. And the beauty is, if another tiny black pup shows up 3 weeks later, you know it's a different one because they don't stay tiny and black for all that long. So looking at photos throughout the season, you can actually get an idea for how many pups showed up on this beach. And then, so this is just a fun little animation of a whole string of photos that one of our interns put together. So you can see it's a dynamic environment. Like the seals are coming and going, and there's a lot of them using it. So, and I think that's one point that maybe I didn't make very strongly when we were looking through that map of how many seals are in different places. But for being a really small, steep island out in the middle of the ocean and having just one beach that seals like to use, a lot of seals use it. Nihoa is a really important spot for the Hawaiian monk seal population. And so that's one of the reasons that we are really interested in getting a better handle on that population. All right, I'll turn that off before it gives us all brain freeze. So, but that whole little that little montage of a bazillion photos gives you an idea. We've got a bazillion photos. Like, this is so much worse than having to look through your grandma's box of photos and try to sort out family favorites or something like that. So like I said, we had over 100,000 photos. We get around 30 to 40,000 photos per year that these cameras are out. So we had to come up with some way of trying to subsample these photos to be able to look at fewer of them and still get good data. So this is what one of our interns got to do last summer, was look at thousands of photos a bunch of different ways. And so basically he took a 4-month subset of photos and split them up in various ways. We're like, okay, well, let's try looking at about a quarter of the photos and do that in different ways. So we could look at all day for 4 days out of 16 days, or 1 day out of 4 days. Or maybe we just look at a couple photos every 4 hours of the day. Or maybe we only look at photos in like the quarter of the day that has the best light, which we decided was from about 11 to 2. And so then we compared all of these different subsets of the data to like how many of the identifiable seals or how many of the pups did these different subset techniques capture versus looking at the entire data set. And so what we found was actually just looking at the portion of the day with the best lighting, so just like that sort of middle quarter of the day, actually did great. So this bar shows 100% of the ID events. And so if we just looked at photos between 11 and 2 p.m., we got 76% of those ID events. And remember, like, huge shark bite girl, she's going to show up, you know, over and over again. So like chances are we got her in that 76%. And we actually got 100% of the pups. So like if we saw a pup looking at every single photo, we still saw that pup looking at a quarter of the photos, because pups don't go very far. So they're still there. So it actually proved to be pretty efficient. And that was better than all the different ways that we looked at of doing a day here, an hour there. So this gives us some hope that we can get the data set down to a manageable level. And then we also came up with a number of next steps, one of which, of course, is potentially thinking about crowdsourcing this sort of thing. So there is a website called Zooniverse. There are other websites and apps where people can, you know, post huge data sets and have members of the public look at them and identify animals in them. But then other things that we need to do, even once we get the animals ID'd from the photos, we have to match that to our databases to see what the IDs are, to figure out who's who. do some, figure out some statistical corrections for seals that might be just outside of the photo range, or seals that are in the water instead of hauled out. And then adding that data into our overall population estimate so that we have eventually a better tracking of the trends at NOAA. And so that's pretty much all I have. And so now I'm open to questions from you guys. Yes, sure.
The photographs would show many rocks. Have you ever used a technique in photography which looks at the differences of two photographs? Now photographs, most of it's still a difference, and it shows what's moved, and we find.
Yes, so the question was using photo techniques that look at the differences between photos. So and so I think the tricky thing is the beach is so dynamic, it makes it harder. So in this picture, yeah.
Okay, then the dynamics is in there. If it's moved, and if they move just like the ones on the beach, you can just see them.
Okay.
One from an hour later. One from an hour later where the rocks have them and the seals.
I don't think the rocks moved off, but
Well, so I guess the issue is, so from season to season, so the sand covers rocks, the rocks get swept out to sea, more rocks get washed up. So day to day or season to season, it changes quite a bit, but I think you might be right. For a small time frame, like an afternoon, it's probably pretty solid.
half hour at a time,
Yeah,
look at it.
yeah, that would be cool to look at.
A rock that's moved, you'll know it's a rock that's moved.
Yeah, that's true. There's probably got to be some sort of human ground truthing or quality checking, even if we loose the computers on it. Yes.
I was wondering if we considered computer analysis type of approach to it.
Yeah.
Maybe look at all, maybe combined with what he's talking about, identifying. Of course, you wouldn't, it'd probably be too difficult to do the identifying parts thing, but you might be able to winnow things down.
Yeah. Yeah. So his question was whether we've thought about some sort of machine learning computer technique to figure out maybe either what's a seal versus a rock, or maybe even which seals are which. And we've definitely thought about it. We've looked into it a bit. And there are some really cool programs that are doing that with animals that are much more splotchy than seals. So there are programs that identify cheetahs by their spot patterns, or even whale sharks and other things, zebras by their stripes, some of those things that have much more dramatic just patterns than seals do. And so we've looked at it for seals, and there's not a readily available free thing that we can just download and use. So I definitely think it's possible. I think it's something that would take a bit of time and money with some actual computer programmers to do it. But really, when you think about it, why wouldn't it in theory, if you had the money and the computer people to do it, it should work pretty slick, right? Because in general, even the things like the little bleach marks and the scars, if our eyes can see it and figure it out, a computer can probably do it better. Right? And it's we're literally doing pattern recognition, going back to our photo ID database and figuring out oh, which seal was it that had the massive scar on her back? Oh, it was that one. So that seal is that seal. And so in the time it takes us to leaf through a photo database, surely a computer system could go through, also a training set of photos to figure that out. Yeah. So the question was, how long have the cameras been on NOAA and how do we get the data? So they've been out since 2013. And 2013. And basically we get the data once or twice a year. So we still have to get to the island to get the data. So we still have to have a successful landing on one of our cruises and get there, and then we swap out SD cards. We take the card with all the data, and then we leave a fresh card to get data for the next year. So basically, it doesn't save us from having to go to NOAA, But whereas we get to land on Nihoa for one afternoon and do one quick seal count, and then we got to get back on the ship and deploy another field camp, the cameras stay out there and get data for a much longer period of time. Yeah. I don't think we have in the photos yet. I'm pretty sure, I think it was just this year. I know Runku, the one that had the eye removed and was released on Niihau, she's been seen at Nihoa. So it definitely, and then of course we had R912, who was nicknamed Nihoa because she came the other way. So there is definitely some transfer. I don't think we've seen a main island seal from the photos yet that I know of. I don't think we have. Yeah.
There's a lot of programs for photographs that's already paid for by the government for different purposes, and that's at JPL. And they've been using high altitude pictures to find, and they've got the algorithms to find there's something moved where it hasn't moved.
Okay.
And they know how to do this. And if we can get some interest in that, they occasionally do things in the.
Okay. And that was what, JPL? Okay. I'll look into that. Thank you. And do you have a question? Yeah.
So I have heard that on occasion you've used drones. So when you go out, I guess, twice a year, are you taking drones with you to access places where you're not leaving cameras that are also very difficult to get to?
The drones are still a work in progress. And so one thing that people might not know, when you're using drones as the government, or in theory, if you're using drones for any sort of commercial or professional purpose, you actually have to be licensed through the FAA. So it takes quite a bit of training and prep and logistics and all that good stuff. But so at this point, I think 3 of the folks on our Monk SEAL team are actually certified unmanned flying system pilots. And we've kind of started doing some tests. We've done some surveys and we've done some studies just to see if it's disturbing to the seals, because of course that's a noise. So we've done, some studies looking at, okay, if we're at 500 feet, nope, no one notices. What if we're only at 200 feet? And do the birds, there's a ton of seabirds out in the Northwest Hawaiian Islands. So far we've mostly just been doing small tests to make sure it doesn't disturb the seals and doesn't disturb the birds. And then we're hoping that that will become a bigger and bigger resource that will make a lot of places easier to get to, or maybe more efficient to map the shoreline of islands and how they change from year to year, in addition to seal surveys and things like that. Yeah. Yeah.
I have a question that's not very scientific.
Sure.
I noticed all the balls on the beach. I didn't see any glass balls. Have you ever run into those?
The question was whether we ever run into glass balls on the beach. And definitely our field campers usually come back with some glass balls that they give as, treats for the cooks on the ship. And I'm sure they all have collections at home and things like that. So yeah, they definitely, glass balls show up, tons of plastic buoys show up, more debris than you would ever wish to see shows up. So yeah, debris, pretty and not, shows up all the time on the Northwest Hawaiian Islands. Yeah.
Because I have friends that have been flying glass balls like you.
Yeah. Yeah, they show up every now and then. You just got to find them before someone else does. Which is easier on deserted islands. Yeah.
Have you ever considered using other types of cameras in conjunction with SLRs like infrared cameras?
The question was whether we've considered using other types of cameras like infrared cameras in addition to the SLRs. And if we have, I don't think we've gotten very far down that route. Like, it hasn't been something that we've planned for. I mean, it could definitely be interesting. I guess I think the main thing is, you look at the resolution we get on nice color pictures in the middle of the day, and then you kind of wonder about the resolution you would get on a nighttime photo with an infrared.
Well, if you use it in conjunction with an SLR, you can identify.
Oh, from body heat.
From the heat.
Got it.
Essentially, you could then have a camera that's every day. So, every half an hour.
Mm-hmm.
So you can see a better picture.
Yeah, that could be cool.
With unlimited money, you probably can come up with some
Right?
great ideas.
I'm pretty sure that the conservation programs in NOAA are up for the biggest funding increases. Putting it out there. Yeah.
How are the turtles on that particular area there? You haven't seen, are there plenty or not?
You know, at Nihoa, I know I've seen turtles in the water at Nihoa. I've never really seen many on the beach. The place where the turtles are just crazy is French Frigate Shoals. That's where, gosh, I think it's like 90-something% of Hawaiian green turtles nest, particularly at East Island in French Frigate Shoals. And so they're just all over the place. And then in most of the bigger, sandier islands in the Northwest, we'll see turtles basking pretty regularly.